I'd like to go over the tabular medley part D. There was a question about it from one of our group. And when you start on part D, the first thing that you need to notice is that I need something from part C. So in part C, we were asked to find the integral from 1 to 12 of f prime of x plus 2 dx. And of course, the antiderivative of f prime of x is f of x. The antiderivative of 2 is 2x. We evaluate it from 12 to 1 and we get 29. Now the reason that's important is the first thing we always try to do when we evaluate a limit is substitute. So the first thing we want to do is substitute this 12 in for x up here. So if I do that, I have the integral from 1 to 12 of f prime of t plus 2 dt minus 29. And look what we've got right here. We've got the same thing that we used in part C. Okay, right here. So this is 29. And 29 minus 29 is 0. And if I evaluate the bottom, if I substitute this 12 in for x, then I have 72 minus 72, which is 0. And we have our indeterminate form, so we can use L'Hopital's rule. And, you know, over the years I've learned to look for clues. Anytime I see this, in the back of my mind, I'm thinking there's got to be some place where I'm going to take the derivative of that thing. And of course, L'Hopital's rule is exactly what we need. We're going to take the derivative of the top. Okay, I'll call the top G. We need to find the derivative of the top, and we need to find the derivative of the bottom. And then we need to plug in 12. So look, when I do the derivative of the top, when I do the derivative of an integral, it is just the function at the top limit of integration. In other words, I am substituting, so this is going to be f prime of x. And it's going to be plus 2. And the reason that we don't think, well, is that 2x or no? Remember that it is just the function, okay? The function evaluated at x. So the function doesn't change because, remember, we're doing the derivative of an integral. So the function doesn't change, we're just evaluating it at that x. So this stays as f prime of x plus 2. All right? What's the derivative of 29? 0. Okay, so we do the derivative of the integral, which gives me f prime of x plus 2. The derivative of 29 is 0. The derivative of the bottom is just 6. And now I need to do g prime of 12 over h prime of 12. I need to plug in 12 here. So I have f prime of 12 plus 2 over 6. And f prime of 12, we come up to our table. F prime of 12 is 1. So I have 1 plus 2 over 6. That's 3/6, which is 1/2. And we have verified that this limit equals 1/2. Nice little problem there, and I'll stop the video.